Hello everybody and welcome to PASCO Laboratories. I'm JP and this week the P stands for spaghetti. That's right, spaghetti. And not just this spaghetti, I'm talking about this kind of spaghetti. This is the traditional tool we've been using to teach electricity. And after 30 years of education, I'll tell you, I've always had trouble going from this to this. More specifically, in a large class setting, well, what's going on with my students? And nowadays, with a distance learning setting, how can I show this to them? It's difficult, but how about if there was a better way? Well, there is, and we're going to show you today live. Let me introduce you to our team. Of course, I'm your host. I'm Dr. J.P. Keeter. I've got 30 years of education, thank you, 30 years of education that I'll be sharing with you today. Also, we have our training specialist, Glenn Starkey. He's manning our cameras and making sure that you see everything very clearly. Our own marketing specialist, Janet Gomez, will be handling all of your questions and coordinating this today. If you've got a question, you just write it to me or you write it to anybody. Janet will make sure that we get that because we're answering it live. Also answering questions today, Brett Sackett. He is our physics specialist, answering them live, streaming them live to you. Joining me here on the set today, our own local hot star, special star, Dan Burns, physics specialist, and Mr. Physics and PASCO himself, J.J. Plank, who, as you can see, absolutely, as you can see from this picture, J.J. is extremely excited about this way that we're going to make your life easier, teach better, and it's called Modular Circuits. But hey, don't take my word for it. Let's go right to the expert and find out more about this exciting product and how you can use it in your classroom. JJ.
Thanks, JP, and thank you everybody for joining us live for this PASCO Live event. I'd like to introduce you to PASCO's Modular Circuits kit. And now this Modular Circuits kit comes in two flavors. The one you see here is what's called the Essential Physics Modular Circuits kit. And this kit comes with sensors, a voltage and current sensor more specifically, but there is another kit called the Basic Modular Circuits kit that is similar, minus a few modules as well as the sensors. And inside either of those kits are a set of circuit module components, just like these. Lots of different types of modules, right? We've got wire segments here like a corner and a light bulb here. We've got modules that include things like resistors built into it, capacitor, potentiometer, LED, and a lot more. And what's great about this kit is these components, they just fit together like puzzle pieces, and we connect them electrically with these jumpers, and we can build circuits just like that, right? And so building circuits is real easy. Demonstrating with these circuits is extremely easy because if you look at the diagram on the modules themselves, they connect to form a complete circuit diagram just like you would see drawn on a piece of paper or in like a lab handout or something like that. And this tool, these modular circuits are great not only for qualitative analysis like I'm going to demonstrate, but also quantitative analysis that Dan is going to show you in just a second. But so we've got, a simple series circuit here, right? We've got a bulb here and we've got a bulb here. They're connected in series. The brightness is about the same. What happens if I open this switch right here, right? We can ask our students these questions. And the way these are laid out and the way that I can demonstrate them like this also lends itself very well for things like video production. If you need to make videos of circuits, demonstrations using circuits, or include them in things like a Zoom broadcast for distance learning. So it's a great tool for all of that as well as in class. So what happens when I open this switch? Well, I open the switch and both light bulbs go out, right? We've broken the circuit, no current's flowing, we get no brightness in the bulbs, okay? We can build simple series as well as simple parallel circuits just like this one, okay? And we can ask our students very similar questions. So we've got one parallel branch, or excuse me, we've got two paths here. Each branch has a bulb in it. The bulbs are the same. This one has a switch in it. What happens when I open this switch? All right, in the previous example, we saw both light bulbs go out. When I open the switch here, only one light bulb goes out, right? And this is the beauty of parallel circuits, right? Something we want to communicate to our students. In a string of holiday light bulbs, if they were connected in series, one bulb goes out, they all go out, right? So modern holiday light strings are made from parallel circuits. One bulb goes out, the rest of them stay lit. And you'll also notice they're about the same brightness, right? So we can do things like simple circuits, both series and parallel, and we can step up to slightly more complex circuits like we see here, which is a combination of both series and parallel, right? And so let me put that battery in there. So we've got a bulb in series here and then 2 bulbs in parallel, but there is a switch that's open on the top here. So effectively we've got one series circuit, one loop. These 2 bulbs are the same brightness, just like we saw before, right? When I close this switch here, I'm going to introduce this top branch to the circuit, and now we'll have a parallel segment. So what's going to happen to the brightness of this bulb right here when I do that? Okay, and so I'm going to throw that back to you guys. I've got a series circuit, and I'm going to add a parallel branch by closing this switch here. What happens to the brightness of this bulb? Is it going to A, get brighter, B, grow dimmer, C, none of the above, stay the same, or D, all of the above, all at once, like magic? Okay, so take a second, think about it. Is the bulb going to get brighter, dimmer, stay the same, or do all 3 at once? Okay, now I'm going to close this switch, and let's watch the brightness of this bulb right here as I do that. So I close the switch, and the brightness goes up. Okay, but you may have noticed this bulb here, it's on. You may not be able to tell because it's so dim, as well as this bulb here. They're both on, but they are dimmer. So the brightness of this bulb went down, and the brightness of the bulb that we had a question about went up. And so what's happening, we've got this parallel branch that we've added here, and the equivalent resistance of these 2 bulbs is actually less than the individual bulbs themselves. So this part of the circuit needed to provide more current to that parallel branch at the top. Okay, and so as you can see, the Modular Circuits kit does an amazing job of providing a qualitative analysis platform for basic and sometimes even slightly more advanced circuits. But in this kit are also things like a wireless current and a wireless voltage sensor. So inside the Essential Physics kit, there's one of each of these. And this wireless voltage sensor comes with leads, like you see here, that we can use to connect across any component in the circuit we want, right? So now we can measure the voltage across this light bulb, right? Or we can measure voltage and current simultaneously, right, using this wireless current sensor module. And the beauty of this current sensor module is it fits right in the circuit. So we can take out one of these straight wire segments and replace it with our current sensor, just like that. And now it is automatically in series with the components in the circuit. And so we can measure the current through our series circuit here if we wanted to. So to tell us a little bit more about that quantitative analysis, I'm going to hand it over to Dan.
Thanks, JJ. I'm Dan Burns. I taught 27 years at Los Gatos High School, and I can't think of a better way to teach circuits than the Modular Circuits kit. Students would learn about circuits in a hands-on way. I'd also appreciate how easy it is to set up and put them away. But what about now, where you might be trying to teach circuits to your students and they're at home? How are you going to do that? Modular circuits would help with that a lot. I'm going to model for you what I might be doing with my students if I was still in the classroom trying to use distance learning. So I have a circuit set up with modular circuits. Got some wire modules. I've got the wireless current module to measure the current in the circuit, a switch, got a 33 ohm resistor, and then something JJ didn't talk about, the wireless AC-DC module. No battery, I'm using that as a wireless power supply. And so I've connected the wireless voltage sensor across the resistor so I can measure the voltage across the resistor and the current through it simultaneously. The sensors and the wireless AC-DC module are hooked up to our software SparkView, which is a free download for tablets and phones. And so what we're going to do is vary the voltage and measure the current and the voltage across the resistor.
Before you collect that, Dan, we've got a question coming
Oh, okay.
With modular circuits, can you build a whetstone bridge?
Oh, the Wheatstone Bridge.
Wheatstone.
Yeah.
Sorry.
Yep. Yes, you can, but you need multiple kits. You couldn't do it with a single kit.
You need extra modules for more.
Which
Yeah.
kits would you get those in?
So you would have to have extra spring modules.
Oh, okay.
So you can do it with the kit plus an expansion kit that we'll talk about in just a second.
Okay.
So this is a little more basic than a Wheatstone bridge, but it's still important. So I'm going to hit start. And so what's happening now is I have the AC/DC control panel sending a 0.5 volt through the circuit, and I'm reading the current 0.01, and then the voltage, I guess I flip those around, 0.49. So I want to save those, so I click the green check mark, and now I have that data in my data table. Let's change this to 1 volt. And so not surprisingly, the current went up and the voltage across the resistor went up. Click that. Now I've got that data point. So I can just keep increasing it a 0.5 volt every time. And pretty soon have enough data to see what's going on. It goes up to 3 volts. There we go. And so now I have all the data I would need to do the lab that's posted in our experiment library, and we also have it on our distance learning page for Ohm's Law. So students watching this video could take this data, even though they're at home and don't have this equipment, and then go ahead and do the lab and do the analysis. As a teacher, you can support them because there are teacher guides posted on our teacher resource page that you can get access to. You'll hear more about that at the end of this, and you can just go to our website. Now, I did say this was an AC/DC module. Here we're using it as a variable DC power supply. What about if we wanted to do some more advanced things with alternating current? Well, let's do something really quick. Let's take out the resistor module and put in an inductor, which is really just a coil of wire. And I'm going to put this compass, which also comes in the kit, by the coil of wire. And then I'm going to turn on the voltage, 3 volts DC, and wow, something happened there. Instead of aligning itself with the Earth's magnetic field, the compass changed because when you move the charges through this coil of wire, it produces a magnetic field which is stronger than the Earth's. What about if we make it an alternating current? I can make it a sine wave, a square wave, or a triangle wave. Let's try sine. And I've got it at a frequency of 8 hertz. I played around with it ahead of time. And so it made the compass move, but it keeps moving. And that's because the current is changing, so the magnetic field is changing. We've kind of created a little motor. And so a lot more advanced things that you can do with this to help your students answer their questions about circuits. The AC/DC module is available by itself, or it can be purchased with our Modular Circuits Advanced Expansion Kit, which JJ is going to talk to you about.
Awesome, thanks, Dan. Yeah, that's exactly right. The AC/DC module, you can purchase it separately, or you can buy it with a kit. And you can also buy this kit separately without the AC/DC module, so there's permutations of what you can buy. But this is our advanced expansion kit, which includes modules that you can't get in the regular modular circuits kits themselves, the basic or the essential physics, which include things like transistor mounts, speaker, diode modules, a DC buzzer. There's a solar panel here. Dan's got a great lab where he takes the infrared signal and amplifies it with a transistor amplifier circuit. And then there's this module, which I find exceptionally useful, which is a 4mm banana plug ports. So you can add whatever you want, custom components to your circuit by just connecting them using banana plugs here. Let's say you have your own function generator and you want to add it to the circuit, you can do so with some banana plugs right there. And then if you want to build more complex circuits like the question we had earlier, like the Wheatstone bridge, and I'm fairly certain you can do it with just one expansion kit, but you can buy what we are calling the standard expansion kit, the not advanced expansion kit, which includes extra modules for things like making more branches in your circuit. If you want to do 3 or 4 branch circuits, you can buy more T's, right? There's a light bulb module that comes with it, 2 more corners, and then a spring clip module, which is great because you can put your own resistors, capacitors, or whatever components you want right in your circuits. And it also comes with more of those jumper clips that electrically connect things. So lots of options. And to help us wrap up, well, first let's go see, are there any questions? Do we have any questions?
Janet, any questions?
No questions yet,
No questions?
Okay, so I'm
We
gonna,
have one question coming in. I'm sorry. Somebody's asking, can these things be sanitized easily?
that's a very good question, JP. So these flat surfaces on these modules lend themselves very well to things like disinfecting wipes, making it really easy to clean the surfaces and the touchable surfaces on those jumper modules. So if sanitization is key, and these days that is definitely key, we've made these as simple as possible to do things like that. And so, are there any other questions?
No other questions.
Okay, I'm going to send it over to JP.
Excellent. Thank you, JJ, and thank you everybody for continuing to watch. And my question to you is, what goes good with spaghetti? Of course, the answer is Parmesan cheese. But what goes good with modular circuits? Student success. And of course, that's what we really want in the classroom, right? Student success. So let me show you where we have resources for you to guarantee this success for your students. In fact, you can find today's video, the entire compendium of student materials, teacher materials, and both Dan and JJ doing this exact lab that you saw today right on our distance learning resource page. But not just that one. You will find a whole load of physics activities that you can use with your students. The list continues to grow, and here's the very exciting part, it's free. Question coming in.
There's a question. Can I buy bulk or single modules?
Yes, that's a great question. Can I buy bulk or single modules? The short answer is currently no, you can't. We have the expansion kits, which you can buy that have those accessory modules in there, but we don't sell them individually.
Thank you, JJ. Keep those questions coming in. For more resources, let me point you to our PASCO video library, where you're going to find videos about our modular circuits, kits, laboratory ideas, and detailed ways that you can connect and provide this type of instruction to your students. Then, also, another question coming in, Brett?
2 more questions.
Awesome.
First of all, how is it different with AC Lab that they currently use?
JJ.
You mean the AC/DC Electronics Lab,
Yeah,
I'm guessing?
Yeah.
So the major benefit of the Modular Circuits kit is the ability to, on your desktop, see the circuit diagram. So when we built circuits in the past in things like our AC/DC Electronics Lab, we did our best to try to make that as visual as possible by organizing where the clips and components get mounted to your circuit. So a lot of the same labs that you did with the AC/DC Electronics Laboratory can be done with these components. It's just in a much more visible and probably easier to use platform for your students.
And a second question,
Another
Brett?
question, what makes this student-centered?
So, okay. So, in my opinion, what makes this student-centered is the ability to see the circuit diagrams on these modules themselves. Make them very easy to manipulate, right? It's clearly laid out exactly what your circuit should be. And let's say I had a lab handout and it said, student, build this circuit right here, and you see a circuit diagram. Oftentimes, it's difficult for students, especially beginners to circuits, to decipher what that diagram is telling them. They can literally put these pieces in the places that draw or lay out the drawing that they have in their handout. So it's very student-centered.
More questions?
Yes, another question.
How long will these resources be free for?
And I'm happy to answer that question. Eternity. They're free. PASCO doesn't have any way to charge you for these resources. All we ask is that you share them. We will ask you to start up an account because teachers need your teacher materials and, of course, your student answers, and we keep that locked and hidden. Sorry, students, I know you were thinking you might get the answers, but the answers are locked. You create an account, we give you those resources. And I'll tell you something else about student-centered. When JJ was talking about how we can kind of demonstrate that, we made these videos student-centered because we don't give the answers. In fact, the materials that you're going to find on the distance learning website are everything that you see with the data being prepared that you can share, but then it doesn't do the analysis. Again, the answers aren't provided. We leave that to the instructor and to the students to discover, and then for the instructor to evaluate. So lots of resources available, student-centered materials, and if you need more information, we have webinars that have been pre-recorded. So we've got Dan Burns who pre-recorded some webinars on getting started. So if you want to know, like, how do I get started with SparkView, which we demonstrated today, or maybe you're a Capstone user, want to get started, Dan Burns has some webinars ready for you. And I understand we've got yet another question coming in. Great, Brett. Let's hear them.
All right. Will this increase the physics understanding, or is it just matching the puzzle pieces?
Well, I mean, in my opinion, this is definitely enhancing the student's ability to understand the underlying physics, because you can do things like the qualitative analysis that we did just a second ago about, you know, hey, we've got a parallel circuit. What happens if we take a bulb out of our parallel circuit? Guess what? Both bulbs don't go out, right? One stays lit. That means one is still carrying current through it, right? So there's fundamental underlying concept here that can be shown in real time using these.
Are schematic symbols on the modules?
That's correct. So schematic symbols are on the modules. There is actually I got a better example here. Here is our potentiometer, and on the potentiometer is exactly how it would be laid out in a circuit diagram. Right? And it's not just the potentiometer. We've got capacitors, resistors, and for those international customers, if you use different symbols, right, the kit actually comes with a set of stickers that have the international circuit symbols on them. What is it, the IECC something?
IEEE.
Yeah, the IEEE, I'm sorry. And so you can actually put the sticker over the symbol so your students will be using and looking at exactly what they're looking at in their textbooks as well.
And JP, is there an answer key?
Is there an answer key? Yes, all of the resources come with a teacher resource guide and the teacher materials that have the answers provided. Also, again, those teacher materials are locked behind the account that you create. So yes, answer keys are provided. And to follow up with JJ, again, like look at this schematic diagram. Can you find the resistor? Can you find the resistor? Now, take a look at this one. Can you find the resistor? And let me do what JJ just did. Let me take out the module. What happened? I don't know, and nobody else does either. That's why modular circuits are so wonderful for teaching this type of electricity. It's an obvious way to do great instruction. I want you also to know, ladies and gentlemen, that you're watching live and we're taking your questions, but I want you to always know that you can reach out to us and we'll be able to answer your questions all the time. Hit me up, hit up Dan, hit up JJ, hit me up. These email addresses are available to you. We're always looking forward to answering your questions. And if it deals with sales, sitting in Texas, waiting to hear from you, we want to hear from you too when it comes to sales, of course. These are great things for your school, awesome for your district, terrific for your university. Reach out to Isaac Martin and let him know that you're interested in making a purchase. It helps support all the great things that we're doing here and all the great things that you do back home. And so, ladies and gentlemen, thank you from PASCO Laboratories here in California. For all of our PASCO people here, we wish you certainly the best of luck, great teaching, and good day.